go live button.
Dan, you gonna put me, Guy, you gonna put me up?
Hang on, let me hit the record button here. Oh, you want me to make you presenter? There you go, Mark. You are presenter currently.
Okay, so. Okay, well, good evening and welcome to the August 2021 meeting of BayLISA, the Bay Area Large Installation Systems Administration User Group. My name is Mark Rovner and I'm the current president of BayLISA. Here today, we also have fellow BayLISA board members, Dan McQueen, Peter Downs, and Treasurer Guy Purcell. BayLISA is held on the third Thursday of every month and its meetings are open to the public. While the world may possibly be pulling back from the pandemic, timing is still not right for in-person meetings such as BayLISA, and as such, BayLISA will continue to be held in this virtual format until not only we feel it's safe to do in person again, but the companies that kindly offer us the space to do it feel so. We hope you will continue to stick with us through this until we can be together again. With the virtual format, we have been sticking to a few new rules. To that, we expect everyone has read the email that went out with the link to this meeting that mentioned those rules. A quick summary is, please keep your audio muted. Feel free to ask questions in the chat, which we will present to the speaker at appropriate moments. And please be courteous and professional in any voice, chat, text, or otherwise. This meeting will be recorded so people can view it later. BayLISA is a membership organization, and we do encourage people to join, but it's not required. Membership fees enable us to pay for various organizational expenses like the domain fees, website, meetup.com, GoToMeeting, and such, so that we continue to bring you the best speakers with relevant and interesting topics. To continue these events, we really do need people to step up and become members. BayLISA can only continue with the financial support from members like you. Individual membership is $45 a year. Corporate membership is $2,500 a year. If you or your organization would like to become a member, please contact myself or one of the other board members, either in chat or later in email. BayLISA is a volunteer organization, and as such, the BayLISA board is always looking for volunteers. If you enjoy these talks, we encourage you to give back to the community and help. It's not hard work, but shared work is always easier. The board meets the first Tuesday of every month. Currently, that is also via video chat, to plan for future general meetings and to discuss other ways to make BayLISA better. Importantly, too, is finding speakers. So even if you don't have time to volunteer, but you know of a topic or a speaker you'd like to hear, or maybe even have something you would like to present yourself at BayLISA, please tell us and we'll follow up. Again, you can contact myself or one of the other board members, either here via chat, email, or the meetup.com site. While we usually take some time to thank our hosts for letting us use their facilities and mention the Wi-Fi access, instead we would like to thank each of you for taking the time to bring us into your homes and to spend some time with us. While we can't provide food and drink in this format, we do encourage you to quickly go get a drink or a snack, so that hopefully we can all feel a bit more connected, knowing that we are temporally, if not spatially, sharing an experience. We have some announcement sections usually. We start with asking if any of the board members themselves have any announcements to make. Guy, Dan, Peter?
I do not.
Okay. We reserve a bit of time for job announcements. We dedicate some time that if you have a job or you're looking for a job or your company has an opening that you'd like to talk about, even in these crazy times, companies are still looking for work and there are still people looking for jobs. If you have such an announcement, say something in the chat and we can unmute you to talk about your job. Don't have a whole lot of people here today, so I'm guessing not.
In my opinion, there are three drivers. First of all is the digital transformation. And you probably run into digital transformation definitions all over the place, but I have one of my own. So for me, digital transformation means an environment where distributed systems share information in real time to solve a problem, or to solve a customer requirement without human intervention. But sometimes you have to have human intervention, but in that case, let's say with little human intervention. Surprisingly, this is not what's happening in a lot of companies, and even large companies. And Mark, I apologize in advance. This is about Apple. Is not really working as well as I would have expected. And I'll give you a story about that. So about 3 weeks ago, I purchased a laptop. And I didn't want to purchase it directly from Apple because I figured, oh, well, I could save a few dollars. And they have resellers such as Adorama that sells it for less expensive. And I figured, OK, let me just order one online. So I go to Adorama, I purchase the Apple. I don't like the fact that it only has 8 gig of RAM. And I said, OK, fine, I want 16 gig of RAM. Well, Adorama says fine, but then you have to custom order. So I custom ordered it, and I add Apple Care to it. Okay, about 2 weeks later, I get the Apple in front of my door. I pick it up, I open it up. Okay, well, let me see where it's Apple Care. I sign up to the system. Of course, Apple Care is not there. I call the service department. They say, well, the vendor didn't apply to the serial number. Well, clearly they didn't because it was custom ordered. I go to the store. They tell, oh, provide proof. I provide them proof once, it didn't work. I provided them twice, it didn't work. So this is my third attempt at Apple to try to add my Apple Care that I purchased to my desktop that didn't have a serial number. They should have had one. So this is just one of those examples of digital transformation. When these services did not function correctly, they were not integrated correctly. And therefore, even today, which has been about 6 weeks, I'm without Apple Care on a product I purchased and an Apple Care that I purchased. So this is just one example, but I can guarantee you'll find examples in any organization you're working with. So the second part is the proliferation of edge services, and there are lots of stories here. And when I talk about the proliferation of edge, I don't necessarily mean your iPhone, even though that's suspicious at times. You may be listening on you without knowing. But if you look at home, for example, you're surrounded by cameras, you're surrounded by alarms, you're surrounded by even Alexa, who's listening to everything you have to say, hoping that you're going to say the word. And then when you go to work, you're surrounded by badges with proximity and motion detection. And with COVID now, you have these infrared cameras that are trying to identify what's your temperature, should you even come into the building. And then more interestingly, when you go on vacation. So right before pandemic, we went on a Disney cruise. And they give us a bracelet that's saying, OK, well, this is great. It opens the door for me. I can get drinks with it. I can do all sorts of things around the cruise, and I can give it to the kids and can get drinks on their own, of course, non-alcoholic. Then later in the last day of the trip, I bought the store that allows you to go and meet with the captain and go through all these backend services and so forth. And we get to the bridge, and the captain says, oh, yeah, great, guys, you all have bracelets. Oh, I'm glad. I said, whoa, what's so special about these bracelets? Well, we find out if a man is overboard. We identify where you are in the ship. And I'm thinking, holy crap. I mean, now they know how much time I spent in the casino. I thought that these devices were just proximity sensors. You put in front of the door, it reads your badge. You give it to the guy to pay the bill. It reads your badge. But these guys turn out to be smart devices. They turn out to actually be able to communicate where you are with the proximity, or find out where you're on the ship or you're not on the ship, and also find out where you're in the casino and probably how much money you're spending. So they know what type of promotion they should send me next time and to come to the next trip. And this is one example. Second example is car manufacturers, lights, traffic control, self-driving, detecting accidents. There are lots of stories when people get into an accident, then you get a call from the companies asking whether you're okay, whether they should send emergency vehicles. Now, if you look at Tesla, they've won a little bit overboard with this. They put a camera inside the car. So it makes you wonder about that now. Tesla claims they don't really turn it on, but if they ever do, give me a feed, because I will need that. I mean, my daughter is growing, and if that's the case, then I'm going to make sure that the Tesla is going to be the designated car for all her dates. So I get a feed into what's going on myself. Anyway, joking aside, there's also migration to the cloud, which is a big deal, right? At the end of the day, a lot of companies realize, in particular, companies nowadays won't actually have to create all these conferences with all the remote workforce. They have to go to cloud. They simply don't have enough capacity to work all their services and so forth. And one extreme case is retail. Now, retail, for example, for Thanksgiving, a lot of companies have to provision, if you're on your data center, about 50 to 100% of the amount of gear or the amount of traffic. They see around 50 to 100% the amount of traffic they see during an average business day. So you can only imagine these companies that run retail and used to have their own data centers, how much it costs. So you have to really be able to overflow into the cloud to be able to scale up and scale down as necessary. And migration to the cloud is also essential for you to get closer to the customer. There's a lot of work being done with customers. For example, how do you communicate with customers in Europe? How do you communicate with customers in their own geolocation? In order to do that, you have to have services that are running closer so you don't experience delay and you give them a better customer experience. So all this is generating a ton of data. I think I convinced you that these are just a few examples. There are probably others. So you're wondering, okay, great, there's a lot of data, but what's the problem? Well, the problem is that in order for you to get value out of data, there are two things that are really, really important. One of them is correlation, and the other one is analytics. So if you look at correlation, what does correlation really mean? Correlation means that you have to take a lot of data from different services and identify the root cause. So just like the slide before, I've showed, okay, is your data wiped out or you just simply don't have connection to it? You can only imagine the amount of problems you have when you're sending those data to a high number of devices, when you have to communicate with the agents to find out what they believe, when you have to communicate with the server to find out what they believe, when you have to communicate, when you have to go down to the log to identify if the server is down, if it's overloaded, if the memory is a problem, if the network is a connection, and so forth. So correlation has deep roots that have to be solved if you're deploying a lot of data. And second is analytics. And analytics is all over the place, from BI tools for business intelligence to Splunk that need log manager or a log manager, or to machine learning, where you have to correlate, when you actually have to get a lot of data come in and identify behaviors, whether behaviors are proper, whether there are anomalies, whether there are trends in the business you should watch for, and so forth. So these two things actually are impacting your business in many ways. If you look at the consumer customer insights, sorry, I can barely read this because it's a bit too small on my screen. So on the customer insights, there are two types of services on customer insights. One is the protect your business, and it tells you how do you interact with your products. Is it behaving properly? Are you getting a sale? Are you communicating with the customer the right way? Are they getting the right response? Are you going to keep them around? And the second is, how do you drive new business? What about proximity? If you, for example, there are a bunch of new services out there, they give you proximity type of information. Waze does that. If you've ever noticed, if you're using Waze, you drive the car and all of a sudden it pops up saying, hey, this is this vendor, you should stop by and buy a drink. Now, you could imagine that a lot of businesses can start building these proximity changes. For example, PayPal purchased iZettle. iZettle has a point of sale contact. Wouldn't it be great if I can walk into the store and get a coupon when I walk in? So I don't have to do coupon clipping, and I don't have to look for coupons beforehand. It benefits them because they make a sale, and it benefits me because I don't have to look for it. And there are lots of services all around when it comes to customer insights. Second is industry trends. How do you know whether a competitor is running a sale? If a competitor is running a sale, will you be able to make a sale? Or they're just going to simply, the users are going to go elsewhere. So you should be able to react to these things in real time. What about if the ship blocks Suez Canal? Go to gas station, get more gas, right? Prices are going to go up, or just get more inventory, because that creates a lot of supply chain problems. Now, if you look at business insights, look at Amazon Logistics. And this is actually a pretty big one. There are last mile problems. Amazon has even gone to the extent to take a picture of the item has been shipped to you to make sure that you see it before somebody steals it. So at least you know that Amazon has done its part. And then really the more interesting part is the Tokyo. So I don't know what you guys have seen that Tokyo has done. In Tokyo, China has done very well during the Olympics. They had a motto right before that. They said that the most goals at any cost. Now, I just read an article recently, and I realized what they have been doing. They have been utilizing a lot of technology for that. So for example, the Olympic rowing team, they deployed imaging technology for them to identify at least performance, posture, what is the optimal way to get the optimal performance out of them. Initially, they deployed a training center, and then later on, they moved all the technology on drones. So they see people underwater. So you can only imagine the amount of correlation that generates for you and the amount of machine learning required for you to get this performance analytics. So bottom line in here is that you need to be able to be a business that actually performs continuous business intelligence. Because if you're not able to do that, your competition will overtake you. So you may be asking, okay, great. So what's the real problem here? So we believe that the real problem here is that enterprises are using legacy technology in order for them to get a new sites and new information out of data. And that creates a series of challenges. So we call this yesterday's technology, technology that has been invented 10 years ago. And I mentioned in my previous introduction, some of that has been written in Java. Some of them has been even the prior Java days. So if you look at what an enterprise looks today, and this is an oversimplification, but you typically find a bunch of services feeding you data and a bunch of services listening to data. And in the middle, you're going to have either an enterprise service bus, such as a TIBCO, or you would have a message queue, such as RabbitMQ or NATS, or you have log managers, such as the one provided by Kafka and by Pulsar. So what happens with Pulse, I mean, just today I spoke with a vendor. It happened to be a service provider, and I'm not going to mention the country, but they're still deploying TIBCO today, and they will not even consider replacing it. And the reason they're not is because, well, I guess I actually don't really know why, but given my knowledge from vendors such as this, they change technology once or twice a decade, or when Juniper upgrades their routers or Cisco upgrades their routers to give a new flavor and maybe a better 4G network. So you can see those vendors are out there. Now, on the second, with RabbitMQ and NATS, it's generally more widely seen. You see NATS kind of deployed in environments where you change a lot of messages, but you change them at the packet level, and you don't necessarily have streaming constraints. And RabbitMQ is similar in nature, but they've been known to struggle with scale, and they've been known to be able to have vendors are saying they have difficulties to deploy them across the organization. But then what we're noticing is that Kafka is considered gold standard. Kafka is known for distributing very well horizontally, is known to give you packet ordering, is known to give you persistence, is known to give you failover. So it's pretty good if you have one, but there are some issues with that. As I mentioned, they are somewhat legacy to some extent. Kafka was built as a log manager. What I mean by that, they were doing log streaming quite well, but then anything you wanted to do in addition to that required different tools. For example, if you want streaming, you need to use KStream. If you want some database bridging, you have to get KSQL. If you want some computational assets, you have to use Flink, and so forth. So all these environments now, you have to stitch them together, and you have to make them work. You have to maintain them, and it's an operational nightmare in various environments. So we are seeing that in this type of environment, when you use these intermediate devices, they're great at what they do, but they do one thing. They help you take data from left and move it to right. And as the amount of data is growing, it creates a lot of issues. High volumes, many data copies, because they don't do much cleaning on the path. They don't actually do much, they don't do anything on the path. They just stream everything to the end, and then Splunk will have to do cleaning. And in Datadog, you have to do cleaning. In Snowflake, you have to do cleaning. Whatever operations you actually take them one at a time and perform data cleaning. Make sure that you get data staying secure. Make sure you get relevant type of insights. Make sure you do correlation on your own, and then make sure that you get it fast, because with all this volume of data is not all that good. So our argument is that, okay, sorry, supposed to move to the next slide. So, okay, this is another joke, but I promise you this is kind of the last cartoon that I'm going to be showing. So it's all about cleaning data. So who wants clean data? Pretty much everyone. Who wants to clean the data? Well, not too many people. So it tells you this is not something a lot of people want to do, but it's needed. Data engineers need clean data and need relevant data. Data scientists need clean data, because otherwise the models are all messed up. And in our conversation with the VP of data of one of the large financial institutions, he said that instead of being bad data, I'd rather not get that data at all. Because as soon as I got bad data to run ML on it, I'm going to start making decisions on that data. And as soon as that happens, that creates all sorts of problems down the line. So data scientists need clean data. Site reliability of engineering, and I'm not going to talk about that because you guys actually know this very well. The access to information, to data, and to the right data is very, very important. And application engineers also need the right data. So then I would argue that the ideal should be a product that enables you to do all those operations in the path before the data goes into their store. Before you get everything moving into Splunk and then realizing that you have license overruns and the data is all dirty and you have to clean it up, and everybody that interacts with it actually has to do their own level of cleaning and figure out what they need to get out of it and so forth. You don't always need all the logs and so forth. You just in some cases you just want the critical information and so forth. So ideally you should have a product that's going to be able to give all the data, all these data products, whatever they need. Splunk needs logs, give them the logs. Don't give them unstructured data. Don't give them information they cannot really read. Datadog needs stats. Give them numbers. Give them the stats they can calculate. Snowflake needs structured data because they're running queries on top of that. So give them queries data. Wouldn't it be great if you actually had a product that can do cleaning up front, that could give you the security cleaning, so you're going to be able to strip out information before it gets to some of these servers, because you don't want to expose everything to everyone. Wouldn't it be great if it was relevant to the context you're in? And wouldn't it be great if you can do all that in real time? I think that I convinced you guys that a product like that would be nice. So why isn't there one? So the reason there isn't one is because it's difficult. And the reason it's difficult is because you need context to run these operations. Every organization is different. It's one thing to send data across, data is opaque, and nobody really has a very good understanding of it. And it's another to send it in context and in context of your application. So this is kind of a giveaway what we do. It was a long-winded lead into what we're doing, but here we are. We are the first company in the market, I believe, that are building this kind of a product. We're building a product that gives you the ability to clean, to secure, to give you relevant information, to give you fast, before it actually into all these data sets. And it's like this operate, in order to do that, some of the issues are quite obvious. You have to be able to operate in real time because you cannot afford for all these data products to receive the operation with a delay. They have to have small footprint and low latency. Ideally, they should have no garbage collection because you cannot really take entropy into the system. They should be able to scale horizontally. They should be able to easily connect into their own open ecosystem. And ideally, they should have programmability built in, because in order for you to apply context to your data, you need some level of programmability to do it. So this is what Fluvio does. We build the first of a kind programmable platform for data in motion. So let's look at the Fluvial layers. Fluvio has 3 layers. And the lowest layer is durability. So what does durability mean? It means that the data stays around. Just like Kafka keeps it around for days to years to so forth, our product also does the same. We use horizontal scale. We use horizontal scale in order for you to be able to process a lot of data. And we use persistence. We use immutable store in order for you to use it as a log manager. So you get information coming in and it's append only, therefore you cannot really change. Once it's there, it enables you to run audit trails and so forth. And it enables you, so the horizontal scale gives you all, the fact that it's scaling horizontally and we have replication built in, you're able to do failover. So if one of the services goes down, then we fail over to the next one, so really you should see no downtime. Now, on top of that, we have the data streaming. So the data streaming platform uses zero copy to ensure that you get speed and you don't have to take the penalty for writing. And why is data streaming important? Well, data streaming is important because you can start chaining elements together. And the streams that represent a certain piece of information, then that's ordered, then you're going to have guaranteed ordering, and you're going to be able to read it back from any level down the stream. So in a lot of these products out there that are particular state for services, they need to ensure there's packet ordering. They need to ensure that information is always processed, always consumed in the way that it's being produced. And on top of the streaming, it's actually programmability. And this is where we are unique. There's no product out there that actually does programmability on top of these 3 layers. It's hard enough to do the first 2. The third one makes this a lot more complicated. So you would think as programmability as something a Spark could do, but they do it in memory. They don't really do it in real time. So they give you a level of computational analysis that you can do in Spark that you cannot really do it on top of Kafka. So what we've done is we applied programmability on top of data streaming through WebAssembly. So what is WebAssembly? For those of you that are not familiar with it, it's kind of a nanoboxing technology. It's a lot smaller than a container, but it gives you good security, and it gives you the ability to enforce good neighborhood, to give you just a certain number of CPU cycles so you don't take down everybody else. So with WebAssembly, we're able to service your data. We are able actually, because we have demos that is running on this, to take the data and give it to your application, write your own custom logic. And you can do normalization functions, you can do protection functions, you can do defining functions right there in real time. Once you apply the business logic, for example, I can give you an example of formatting. For example, if you get unstructured data coming from logs and you want to make a JSON log out of it, then you can do it there. You can format the data, you can run regex on it, because we expose the programmability in your favorite programming language. Now, we say that today is exposed in Rust because that's the platform it's been built on, but anything that converts to WebAssembly you should be able to use. And then the packet, we are going to move the packet up. Our technology does it, give you in binary format, and then you can format it, you can transform it, you can mask elements that are not relevant, you can normalize it. And this is great for machine learning guys that are getting a bunch of null values or a bunch of information that it's inaccurate for them to run machine learning on. For example, the zip code is messed up, or the address is inaccurate, or it doesn't match the city and so forth. So with our technology, you're able to do this predictive type of operations in real time, if you know what they are, of course, because not everything is suitable for real-time operations. There are going to be times where you want to shove everything in a database and take it from there because you need to normalize at a higher level. You need to look at multiple different fields to be able to derive information out of it. But this is for problems that are obvious. The problems that when a city it hasn't been set correctly or is mistyped, you're able to correct it. And also on the part where null values are coming around, they definitely mess up your machine learning. So null values, why do you even bother about them? Why don't you drop them right at the data into your network? So this is pretty much the normalization function. Make the data clean. It enables you to format it, to transform it, or to remove bad elements. Now, on the protection front, I would argue that not everyone should see your social security numbers. You have the ability to mask fields out. You have the ability to tokenize them in real time as soon as they hit your network. They hit your network, and then you provide the key to whoever should have access to see that information and nobody else. That makes sure that you have built-in protection, and the information is deemed protected, and they should not be accessed. It will not be. And also, you have the ability to strip. For example, if you don't want, there should not have been a social security number, or there should not have been a credit card to begin with in that packet. You have the ability to strip it out. And the last one is refine. So we are getting all this information across in our network, and then you can apply filters on it. You can apply aggregates in it. You can derive new data sets on it. So once you store the data in our immutable queues, you can actually derive a new data set from it. And you can go back in time and do it at any time, and you can learn new insights from that data per se. So that this is where it becomes very interesting. For example, one of our examples, we retrieve traffic information from HealthCity to MQTT. We get all the bus information in real time. But what about if I'm interested in bus number 1? Do I have to go through everything? And what do I know where it is right now? With our technology, you're able to write a smart stream. You're able to write programmability, fish out all the fields that are labeled with bus number 1, and just look at those. What about bus number 2? You can use the same data stream and fish out the items that are labeled as bus number 2 and consume those. Now, that hopefully it shows the value of having the programmability joined with the data streaming, and also be able to look back in time. For example, I'm interested, how accurate was bus 1 versus bus 2 yesterday within a certain amount of time? You can run that analysis by looking back in time. So we have all these capabilities built in. So as opposed to a Kafka or a Pulsar, we have immutability, which they have as well. We have data streaming building, which actually have to apply another product on top of them. And we have programmability on top of that, which none of them do. In order for them to get programmability, you actually have to recompile Java and try to integrate somehow in Kafka. Now, you can do it to connectors, but that means that all the traffic has to go out of your network, at least out of your product, hit some sort of a connector, hit a third-party product, do analysis on it or some sort of analytics on it, bring it back in, and then you continue down the path. If you want to do analytics with our stuff, you can do simple analytics, and then we can send it on to the tools from then on. So I hope I convinced you that this is a very interesting product, and you guys should take a look. Now, before I talk, I show you guys how it works, I'm going to tell you a very high-level diagram. Now, I'm not going to spend too much time in here because it's noisy. But what I'm trying to say is that the Fluvial architecture took us a couple of years to build and has lots of components. It has a client component that it has a bunch of sources built in. Now, just to close out there, we're still working on the connectors. They're not quite there yet, but they're coming. They're going to be out there in a few weeks. We have a client that is built that enables you. It has a very powerful CLI, enables you to do cluster management, enables you to produce and consume. It enables you. We have 5 different APIs in 5 different languages that enables you to do produce and consume from them. It enables you to administer the function. So you can run Go, you can run it in Python, you can run it in Node, you can do it yourself. And then we can run on multiple infrastructure types. For now, we're in AWS. It runs on top of Kubernetes. We compile the client compiles in Windows, compiles in Mac, compiles in Linux. The server itself compiles in Mac and Linux, so you can deploy pretty much everywhere. And then you have the processing engine, which I talked about and I described in detail. So the processing engine has 2 terms. One is the streaming controller, which is the SE, and the streaming processing unit. And we have clean separation between control plane and data plane. And that's very beneficial because you can apply this technology to a lot of different use cases, in particular hybrid use cases. With Kafka, you have a hard time to do that because the controller moves into the brokers, and then good luck. You don't want that controller to actually all of a sudden gravitate towards your branch because it's going to mess up your entire architecture. So that's why for us, the controller is actually isolated. And then the SPUs they can expand. And they can expand horizontally, and they can expand horizontally in the cloud, and they can only expand on your own virtual machine, that's what you prefer. So we have managed and unmanaged workloads. On top of that, we have the streaming platform, which is partitions, topics, partitions, replications. And on top of that is all the small streams that I described. So this is pretty much what I want to say about technology. And I claim that it's not going to be very technical. And I hope that I kept my word. This is pretty much the most technical slide that I have. But let me tell you a little bit more about the product now. And what does Fluvial mean? And what does the cloud mean? So we created Fluvial, which is open source. And we claim that Fluvial will be open source forever, which is true. We will never change that. And the Fluvial open source has all the building blocks required in order for you to run this product in production on your own environment. Now, clearly, I believe that the community has been adopted quite nicely so far. We just put a word out there that we have a version. We told people what we're doing a couple of months ago, and I believe the interest has exploded. We've acquired around 560 stars. We've gotten a bunch of users on Discord, which are communicating with us on the daily basis. We get over 20,000 downloads in Docker Hub. So I think that we're demonstrating that there's value to what we're building. And a lot of use cases that are coming in are really Kafka related, that people really don't want to run Kafka because it's difficult to operate. If it's not a very complex use case, then they want to run something lightweight, and they believe that we are it. Now, we're not for light use cases by any means. We build this platform to scale up to a Verizon type of network, and we believe our small footprint and our distributed system is more than capable to handle that. Now, what is Infineon? Infineon is the enterprise version of our product, and everything that actually we are going to charge from later on is going to be labeled there. So we have an Infineon enterprise version, which has all the building blocks that enterprise vendors would want. Things like multi-tenancy, things like RBAC, things like team concepts, and so forth. So what is really Infineon Cloud? It's really a certified version of Fluvial open source plus a bunch of glue that is required by enterprises to run. And that's the product we want to charge for. Okay, so that's the way we're going to make money if you're wondering if you're going to be around next year. Okay, so a little bit about the product, and I hope this is going to go relatively fast. I only have 3 more slides, so bear with me in case I'm long-winded. So in order to get started with Fluvial is pretty straightforward, actually. It's a 3-step process plus parse streaming, which I call the experimentation phase. First of all, we have a client. All you have to do is download it, and as I mentioned, we compile it to all these different environments, which are listed there. Then you have 2 options. You can install a cluster on your own, or you can run our cloud cluster, which is a version that we installed for you, and you don't have to install anything. Just point your client to it, and you're ready to go. If you decide to install your own, we made it very convenient for you. We have, as a part of the CLI, you're downloading actually all the binaries required for you to install a package. So you just run in the CLI, Fluvial cluster start provisions the cluster for you. It provisions on your own local environment in Kubernetes, if you have Minikube running, KT3, if you have Linux running, and so forth. So we hope that we made that very convenient to run on your laptop. If you want to run the enterprise version, we have Helm charts that can help do that if you have your own Kubernetes environment. And then after you're setting all up, then you're ready to produce and consume. So for producing consumers, you typically attach, you add a client. If you actually want to build your own clients, then attach a connector if you want to consume into it. And since you guys are familiar with Kafka, I'm not going to dwell too much on that. It's about connectors, which are connectors for the source and connectors for the same. And just a quick clause over here, the connectors are still in development. We have the prototype version, and we're gonna, but we'll have them ready for consumption sometimes in the next few weeks. Okay, so after you do all that, you wonder, okay, you talk about programmability. So what does programmability really do? So I've just set up 3 slides over here to show you guys the 3 different programmable interfaces that we have. We have filters, we have maps, we have aggregates that you can join together to create all those, the 3 phases of the pipeline that I described. So what does filtering do? Well, filtering just takes a bunch of raw data and filters out what's not relevant. It keeps just keeps the fields that are relevant for you. So as you can see in here, this is actually a working demo that I'm going to show you guys, and it's actually published on our website. And right after this, it's a quick 1-minute demo. So as you can see, all it takes is really 4 lines of code to be able to filter out something very simple, like lowercase apple from a stream of lowercase and uppercase characters. So hopefully that demonstrates that you can do that in a few minutes, and then you push the button, all of a sudden you are able to get a new set of data from your existing data stream. Then we have maps. So what is maps? Maps, you're converting information. So this is what actually the masking of credit card information would come in. So for example, this is an example sample code, and you can see it's not a whole lot. It's just about maybe 10 lines of code that enables you to run a regist function, and it gives you the ability to find a social security number and mask it. All that, bear in mind that the raw data is still there. So if another consumer comes in and needs to see the social security number and has the privilege to do so, he can freely do so. And then we have aggregates. So what are aggregates? Aggregates gives you the ability to do computation on the data. So for this simple example, we just show you how can you start accumulating numbers together. So for example, we're adding 2 to every one of those numbers. So an aggregate is just a number. You can compute aggregates out of everything. How many sales do you have? If you're wondering if a users have too many drops, have too many 500, then you can count those and you can identify them. And one of the examples we had is that you can build composite aggregates. So the example we provide, and we're gonna publish it next week, is we were wondering how many stars do our products get. So we're adding aggregates to say, okay, Fluvial got a new star, so we have a key which is for Fluvial and the number of stars it received. And then we also have another product that's quite popular called NodeBindGen. So when NodeBindGen gets a star, he's going to get aggregate. NodeBindGen is going to get aggregated in for a star. So the end result is a composite JSON structure that gives you all the aggregates for all those stars together. Okay, so that's all I have to say about the product. Now let's do a quick demo. So for the demo, as I said, I just went ahead and recorded this so I don't trial and error, and also it's a little bit faster if I run it on my own. So let's just get this one going. So what do you have over here? So maybe I should just explain a little bit before we get going. This is an installation of Fluvial Cloud. So when you sign up, you're going to get the cluster view, which is the first view that you had in here, and you get a topic view. So in the cluster view, it's going to tell you how much data you can store, if you're up and running, if your customer is healthy, and so forth. Now in the topic view is where when you're actually adding your data streams. You create a topic just like you do with Kafka. So let's go ahead and do that. You create topic. We just create the topic name because right now we're just giving replication factor 1 and partition of 1. The topic is created, as it says, partition 1, replication 1. Now, if you install it locally, you can set up as many replications as you want. And well, not quite. Replication factor is actually, it's based on number of SPUs you have deployed. And since in this demo, this is alpha version of the product, we only give you one instance of SPU in the cloud because we don't want to deal with the cost issues that are surfacing. But if you run it locally, you can set up as many SPUs as you want, and you can set up replication factor of 3 and beyond. And once you go to production, we're going to have 2 different clusters, one with replication factor 1 that are optimized for logging. And we see a lot of users for IoT because what happens, our image actually compiles in Raspberry Pi. And we see a lot of users just want to do log streaming and they don't need the replication. But if you're running this in an enterprise environment, you want to have replication and you want to have multi-zone replication. Anyway, so I digressed a little bit. But this is the idea, is that that you're setting up a record and you get a partition of 1, partition 0. And now you click on a partition and you're ready to produce and consume records. And by the way, this is running on a cluster. Whatever you type in, you can see how zippy it is. You're typing in, it produces, it goes to the cluster, and then the consumer reads from it. So we're using WebAssembly that communicates with the cluster real time, and you have one producer, one consumer, and each of these boxes are communicating with one of them. Even that's kind of innovative, we believe. And then let's say we want to go to smart streams, and now let's apply a smart stream function, the one that I've just shown you, the ability to filter A from the stream. So it takes a bit of time to compile, but you can show that it's real. It compiles, and then it retrieves, it's fetching the records. So you see, it's fetched all the records with lowercase a. And now actually it fetched all the records from the beginning of stream, but it can continue for your live stream. So, or you can apply this when we offer offsets, and actually you can do that on the CLI. You can offer an offset and say, you know what, apply the off stream only for the last five items. So okay, so I digress here. So what is happening here? He's actually, we updated the lowercase a to uppercase a. So we show that this is not only for one environment, but it's multi-environments. Now you can have multiple streams consuming with different type of business logic. One of them is with lowercase a, and the second one is capital K. So this just happened to be in the same context. But you can have as many numbers of consumers as you want, applying different smart streams to be able to get different results from the raw data. So here it is. We're typing on our values, and again, you can only see capital letter values. And now, to show that this works across multiple environments, here's the CLI that's sitting side by side with it. So now from the CLI, we're going to read from the same topic. So if you consume from topic fruits with B, which is from the beginning, it gives you all the items. Now, if you produce to that, now you're going to see that in this case, we're producing eggplant. As you can see, the eggplant showed up at the top because that's producing everything, but it doesn't show in the web browser because that's using smart streams to filter that element out. But if you're timing cranberry, here we go. They showed up in both. They showed up in the cloud, and it showed up on the CLI itself. So this is pretty much it. We hope that this was entertaining. I hope that at least it was that we've proven that this product would add value, and it's there, it's real, it's ready for use. Okay, and last slide. At the roots, we're an open source company, and pretty much I would say that around 90% of the code that we're building, it's inside Fluvial. So we encourage the community to join. We have a website, we have a GitHub repository, we have a Discord, and join us in building the operating system for data in motion, because we believe that when you apply programmability to data in motion, you really get an operating system, and sky is the limit in terms of the functionality that you can apply in this environment. So thank you very much. I'm ready to hand it over to Mark, and if there are any questions, I'm happy to answer them.
Hey, that was a great talk. A lot to think about there. Stuff to try out later too, seems like. I don't see any questions here in the chat, but Dan, are there any questions on the YouTube stream? If you have questions, just mention in the chat here, or if you're on the YouTube stream, mention it the YouTube chat, and we can bring up your question.
I don't see any on the YouTube stream.
Well, if you guys have any questions, I'm happy to answer.
I don't have a question, but I have a comment.
Great, thank you.
and that is that this seems really cool, and I say that coming from the company that where Kafka got its start.
I actually have nothing negative to say about Kafka. If it hadn't been for Kafka, we wouldn't be here. We noticed, and actually, by the way, we built the replication engine that Kafka has. We just built it asynchronous, and we built it from Rust, from the ground up. At some point, we were actually packet compatible with Kafka. But when we built this, because ideally we wanted to be just the feed from Kafka, and we don't necessarily want to replace it, by the way. We believe there's enough business to be out there, and Kafka does well in some environments, but with the programmability, I think you're going to be able to get something extra. And I'm happy to talk to them. We're happy to partner with them. For Fluent, actually, if they're interested, they're a big company. Surely they're not terrified by us, a couple of guys in a garage. Actually, I shouldn't be saying that. We're a team of just about 10 people now. So, and we're proud to say that we have some amazing engineers. But I think it's great technology, and I think we're taking it somewhere where some of the other vendors have not yet taken it. And we believe that Java is kind of an impediment to get there, because that ecosystem it requires a lot. It's expensive to run, and it's hard, and nothing to do with Kafka. I think if Kafka had been built on a different programming language, I think it would have been great. But they built it at a time when Java was popular, so I guess that's a consequence of that. I think, by the way, the protocol and we could have used Raft for all the negotiations that our nodes are going through to keep the leaders and followers around. But we believe that the Kafka algorithm is just simply superior. Well, thanks, guys. So actually, that tells me that you work for LinkedIn.
Yeah, I do.
Yeah, great company, by the way.
Thank you. Yeah, I've been there a long time, and I really enjoy it.
That's great. Well, thank you, guys. If there's nothing else, I appreciate the time. And if there's any interest in this and you want us to do later on a deeper dive, or if you'd like to do some demos that are more appropriate to your audience, to the IT community, we've spoken to SRE people in the market, and clearly our product doesn't hit the mark quite yet because it's still bare bones. We were told that, okay, this is great, but you know what? I have enough tools. I don't need another one that is going to take me a year to bring up. So we need to make it very easy to get on and start immediately giving you some actionable events, or show you how you can get from like hours of troubleshooting or hours of finding events or finding root cause to minutes. And we believe the filtering functionality will enable you to build programmable logic that you actually can share later on. And once you have a pattern, you identify the pattern, you apply it, and then it stays there forever, and you can get notifications on it when it happens again. But we're not quite there yet, and we hope to get there sometimes in the next year or so.
I wish you a lot of luck with that.
Thank you. Very cool. If we don't have any questions, I guess we'll wrap this month's meeting up. We thank everybody for showing up. If you have any comments about how the meeting went or things you liked or didn't like, we're always open to hear those. We do have a speaker all lined up for next month. ENV0 will be speaking on the pitfalls of infrastructure as code. Announcement is up on the website, and we will be posting that in the email soon. So be on the lookout. Thanks everybody for joining us. Thank our speaker, AJ. Thank everybody for being here, and we will see you again next month.
Thank you very much.
Awesome. Night all.
Good night.